So in this lecture, we will be covering the Kaggle competition of Titanic dataset. So first we go to the kaggle.com website and go to compete and open up the Titanic machine learning from disaster dataset competition. So when we open that link, we'll get this details of the competition. From here you can go through this. It's a simple competition to determine whether given details about given the details about passenger of Titanic, what are the chances of his survival? Would he have survived the disaster or not? So that's the competition requirements. So this is my attempt on the Kaggle Titanic data set competition. So here I have given some introduction about the competition. And now I have imported the required packages. We as usual need pandas and numpy, and we also need the graphing and charting libraries of matplotlib and seaborn, since we need to show how our data looks before using it actually for training the model. And we also need the simple imputer from sklearn so that we can handle null values, and we also need one hot encoder. It simply encodes the different types of categories data into integer values. So next we load and display the training data. So we have the variable train underscore dataset from pandas.readcsv from this URL. The URL is here. This is our data full dataset in the Kaggle directory. From input we are reading the train.csv file here. So the training data is loaded in this variable here, this statement means, and from that we are displaying the top 50 rows of that CSV file here. So next we load and display the testing data. So the test underscore data variable contains the test.csv file as a pandas data frame, and we print the head that prints the first 5 rows of this testing data set. So note we don't have the survived column here because we need to determine it from our model. We need to predict the survived column for this data set. It contains all the columns of the training data set except for the survived one. So after that I have done some analysis that you can see for yourself from the uh, file I have given the support material for this lecture. It's a Python ipynb file, Jupyter file. You can run it on Anaconda. So I have also done some feature analysis, and you can see how I combined few columns into one, and for others I optimized the data set. So you can do the analysis. I'll quickly move on to the modeling part. So first we take the survived column of our training data set in a variable named y. So uh, for all the rows it will contain the corresponding survived value. Then we have the features as the columns of all the columns we have generated so far from the analysis section. Next we use the variable x, capital X, which have all these features from the training data. So the X will have all the features except survived from our analyzed training data set, and we print the head of that. So Next we have x underscore test, which will be from the test data for the same features. So this is what we'll pass to the our predicting algorithm. So after that, we need to one hot encode our model so that we can handle the text categories, because our machine learning algorithm cannot uh, differentiate between text categories. So we need to one hot encode it to integers so that it can differentiate between them. So this is the algorithm, I mean this is the code for that. Finally, we'll be having the final training and final test from the X and X test uh, datasets respectively. That will be one hot encoded. So this is from, I mean, final underscore train is the one hot encoded version of X, and final test is the one hot encoded version of X test. Next, we import the train test split library from sklearn.model selection. It will help us to uh, split the training test data set into uh, training and test data sets respectively. I mean training and test samples respectively. So the training data, which is final underscore train, is split into training and testing samples here, which are X training, X testing, and Y training and Y testing respectively. So for training it will be XTR and YTR, and for testing it will be XTS and YTS. Sorry. So now we handle null values in our X training data set with simple imputer. So this is a library given by Kaggle to handle null values. Simply we need to use the module of simple imputer and transform it to get the final data with imputed values. And we're going to use this variable here with imputed values to fit our model, because this is the training X dataset. So from sklearn we'll import tree for decision tree classifier. So I'll be using this here. So first we'll fit the dataset with this variable against this training y. So as you know, training, it will train the model. It will make him understand that for this types of values we need this y. So next we fill the final test data set against which we will be testing our model with null values. I mean sorry, with null values replaced with 0. So fill NA does that, and still sometimes we need to use the numpy test. I mean numpy replace np.nan with 0 function, because sometimes this function doesn't do well enough. So after doing all that, we have the final test variable ready for prediction. So we predict our model, uh, I mean predict our data set final test on our model, and finally we submit it to Kaggle with this submission.csv. So this decision tree classifier gave me a score of 78 percent. So my model was correct for 78% of the data, test data I mean. But if you use other algorithms like support vector classification and all, you will get better accuracy. So that was all for this lecture. Thank you.